All right, so there's some accusations that some of my filters don't do anything, and I guess that accusation is correct. Now it actually does something, but you have to use the tile brush to make it happen. So you can see that as I'm clicking, we actually are getting something happening. Now, why doesn't filter 21 do anything when we apply it to the entire image? Well, this filter feathers black and white around the edges of the image, right? But PHOSIMP is designed to perfectly tile, right? So if we apply the filter to the entire image, there's no edges. And so this filter is designed to work with edges. So if we don't have any edges, we don't got anything to work with. Does that make sense? So like here you can see that around the edges, we have like black and white. We're kind of fading into these black and white edges, right? And filter 21 is actually the opposite of filter 20, right? Filter 20 does it the other way. And once again, if there's no edges, we don't really see anything happen. So you can see that as we use filter 20 here, you see that there's a little bit of color on the edges there. Now, maybe the way we kind of ramped this was bad because the ramping is very subtle. But the reason the ramping is so subtle with these filters is because they were originally inspired by like an optical illusion where it's like, this photo has no color, blah, 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 right? So if we do this, right? Are you familiar with that optical illusion? That's what filter 20 was originally for, right? But when you just use it on the entire image, there's no edges, and therefore everything ends up black and white. And then for filter 21, 21 is the inverse, so if there's no edges, you just get color, right? You just, nothing happened, right? Let me go check my messages, make sure that no one, okay. So anyways, so filter 21, right, if we use it on the entire image, nothing happens, but if we use it like this, and we click, and then we get rid of it, you can see how this is kind of the inverse of doing 20, right? If we do 20, right, but we do it on the entire image, right? So let's go do it on the entire image. You see that 20 and 21 are inverses of each other, right? Hence that we see that 20 is feathered black and white, and then filter 21 is feathered inverted ba for black and white. So hopefully that kind of makes sense. Okay, so filter 22, let's go look at that. Okay, so filter 22 is sub-pixel quad halftone, as we can see from the vertical text. And this is a pretty cool filter, but you really can't see what it's doing unless you zoom in after you use it. So we're going to use 605 to zoom into the center, and we're going to zoom in a bit more, and a bit more, and a bit more. And so here what you can see is that the pixels are either red, green, blue, or white, and they're shades, right? So the white is actually like a shade of gray. It could be black, right? And then the green is different intensities of green, different intensities of red, different intensities of blue. So what we're basically doing is we're saying that instead of one pixel having red, green, and blue, as is the norm, we're going to make clusters of 4 pixels that behave like a pixel, right? Yeah, it's a cool idea. There's like people who do like whole videos on what a subpixel filter is. But yeah, I think it's a pretty cool thing, right? Now, the cool thing with the subpixel filter is when you mix it with a pixel shuffling filter, what's happening is a much more obvious. So remember how we said in a previous video that 11 is kind of shuffling the pixels, but it's not actually resizing things. It looks like it's resizing things, but filter 11 is not resizing things, because if it was resizing things, you wouldn't be able to loop all the way around like this, right? So for example, filter 10 here is actually resizing, and you can't loop around, right? Because once you size it down enough, everything is a flat color, right? So obviously when you demonstrate filter 10 and 11, you can see the difference after you use it a whole bunch of times. Now, if we do 10 and 11, but we use 20 first, so if we use 20 first, actually, sorry, 22, the subpixel filter, right? Now if we use 10, we see that everything kind of shifted to red once, and that was just because of the way the image gets downsized the first time, right? And we see that we have a solid color, right? Okay, now if we do 22 and we do 11, which shuffles around the pixels, check this out. That was not what I expected. I did not expect everything to go red. Oh god, does this filter have a bug in it? I think it does. I think it might. No, yeah, because I think that, yeah, oh no, there is a bug in here, because this should loop around, but it doesn't. it like the first time it ran, it like discarded one quadrant of the. I mean, if that's the way it works now, that's the way it works now. But that's not really what it should be doing. It should be redistributing the pixels. Did it downsize and redistribute? You can see that it loops around, right? You can see that filter 11 does indeed, is indeed shuffling pixels, but it's not looping around. And the fact that I can do the subpixel filter and have red, green, blue pixels, right? But I use 11 and I only get red, and red is like the top quadrant. Okay, that's actually kind of... Maybe this is a lossy filter, but the mirroring... Okay, I'm actually kind of confused. Okay, so this either has a bug in it, or it's not doing exactly what I think it's doing, right? Why am I confused? Well, here, I'll show you why I'm confused, right? We're gonna use 22, and then we're gonna do a different shuffling filter that I know correctly shuffles pixels, right? 1111. If we use this, see how we have the color, right? Remember how we had the red, green, blue, and white pixels, but now they're redistributed into the 4 quadrants. Redistribute, 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 right? And if we keep on redistributing, eventually we get back to where we started, right? And you can see that by using filter 22, it makes it a lot more obvious that we're not downsizing the fucking image. Oh my god, I'm fucking choking on like popcorn that I ate like 3 hours ago. Why is my throat? Oh god. We gotta pause the video. Do we have a pause button? We do. Alright, unpausing. I got some wine to wash that down. Okay, so actually with filter 11 here, I am kind of disappointed that I didn't catch this. So, what are we gonna do about this? Well, the thing is that filter 11's been around for a long time. Even if there is a bug in the way filter 11 works, we'll just have to create another filter that does not have that bug. Now, why is that? It's because backwards compatibility, right? If there actually is a bug in filter 11 to where the first time we use it, we should actually see a red, green, blue, and white quadrant, which I'm pretty sure we should, but then I'm very confused at how it like loops around. It loops around, but there's information lost the first time, right? There's information lost the first time, but then after that, it loops around. That's actually quite curious. Now, this is a low resolution image, so we might want to actually load something else in that is a higher resolution image, because that image is actually 128 by 128 pixels, and PHOSIMP works with 512 by 512 images. So every single pixel in that image has actually been scaled up to like a 4x4 chunk. So we could open up the not safe for work folder, but I'm pretty sure that would be violating Twitch's terms of service. I think they're all clothed, but you know, like let's not thirst trap. I'm tempted though. Here we go. We'll thirst trap with this. Okay, so this is full resolution, right? So I'm just curious as to if we use this, if it's not going to loop around the way we thought, right? Like, because this has more resolution. Okay, no, it's still looping around, but right, for some reason, the first time we do it, it loses information, or maybe it doesn't lose information. It's just the way the odd-even cycle of mirroring and interlacing, the way it just works is it just never will loop back. Or actually, it might actually loop back after a few loops. So we might actually want to use this a few times, make sure that we're not losing our mind. Okay, we're losing our mind. So that is quite curious. Now, this was one of the early filters, right? Because we're still on filter 11 here. And so at this point, I didn't quite realize that, oh, we can do the reverse of these kind of filters, right? So from now on, if I made a filter like this, I would also make the reverse, right? So for example, you know, with 5 and 6, right? If they're redistributing pixels, we should make the inverse, right? And the inverse should be right next to it. 11 doesn't have that because, you know, it's not, it was a while ago. It was before I knew what I was doing, right? I'm learning what I'm doing as I make it. Now, I do think that we should go look in the source code though and look at filter 11's code, because I'm actually like, oh my god, was that 11? Yeah, 11. I'm like, wait a second, aren't we doing filters 21 to 30 up here? Why am I on 11? Oh, it's because as I was explaining things, we found something weird about filter 11. So I'm going to go filter PHOSIMP 011 in the source code. I'm going to search for that. So we see here is the function for filter 11 right here. I see that there's a little explanation here called 4-square axial mirror. If we grab onto this, we'll find like a little explanation, right? So that's basically what I expect. So we're redistributing the pixels, shrinks down the selection area and pastes it 4 times. Okay, that's interesting. It's saying that it just shrinks down the image. Oh, okay, I see what's happening. Okay, 4-square duplication, right? We just shrink down the image and we paste it 4 times, right? And then here, we're not actually redistributing the pixels, right? We're shrinking it down still, and then we're flipping it and flipping it and flipping both. Okay, I see what's happening. The mirroring that we're doing here is unintentionally redistributing pixels by changing the way the image downscales. Does that make sense? So I lied. We're not actually shuffling pixels. We're not actually shuffling pixels. It's just that by flipping stuff around, it's changing the way the image downscales each time. And I don't know exactly why, but for some reason, this flipping is preserving information, right? It's preserving information in a similar way to how shuffling the pixels around to downscale preserves information, but it is a fluke. I did not expect that to happen. I don't know how the math works out, but we're obviously observing some type of preservation of information that was not intentional. It was absolutely not intentional for filter 11 to loop around like that. And now I realize why filter 11 doesn't have a filter 12 inverse, right? Like filter 5 has an inverse of 6, right? We can do 6 and then 5, or 5 and then 6, right? 12 is not the inverse of 11. Why is it not? Because 11 was not actually designed to loop around, right? 11 was not designed to loop around. Somehow we just had like a very happy coincidence of interesting behavior emerging that I did not plan for. So, okay, now I know. Okay, so we're supposed to be explaining filter 21, 22, all the way up to 30. So 21, right, it isn't doing anything because it only works if we press the delete key and use the tile brush on a subsection of the image, because this filter only works on edges, right? And then same thing with 20, but that we explained that in the previous video, right? 22 right here is the halftone filter. Sorry, 20, did I say 21? 22, I'm a little bit drunk now. 22 is the halftone subpixel filter, right? Which we explained that, you know, if we zoom in, we see that it turns every pixel to a solid color of red, green, or blue. It would be nice to do something like this, but instead of red, green, and blue, and white, we could use like cyan, yellow, and magenta. I should put that in my notes because that would be a fun little filter. I don't know where to put that note. So this is kanji code or PHOSIMP, so we could just, I don't want to put it there. Do we want to go to the Discord server really quick? So let's go to Chrome really quick, and we're going to go into feature requests, and we know that it's filter 22 that we explained, right? We need to make something like filter 22, but it uses cyan, yellow, and magenta. I think that would be really cool, right? So we're going to go to Discord, our Discord server, and we are going to put that in the feature request. Now, will it ever get made? I don't know. There's like, I'll be dead before I make all my ideas. And is that a tragedy? I don't know. There's no non-tragic way to die, right? We can either die before all of our cool ideas are made, or we can make all of our ideas and then we can become washed up and be like, your best days are behind you, you're no longer creative, and then you can die, right? So really there is no there's no non-tragic way to do it, right? You either die before you've created your full masterpiece, or you become washed up because you created your own masterpiece and then you went on to be pathetic and not do anything interesting with your life after that, right? So sometimes there's no way to win, right? And I think that's important to know, that sometimes there's no way to win, because it's kind of like when people are like dragging you through the mud when you like say something bad on the internet. It's like, if you said one thing, they drag you through the mud, and then if you said the exact opposite, you can also PR spin that to sound bad. So like, I don't know, don't get into fights on the internet. I don't know, write code. I don't know. Anyways, so we're gonna go find feature requests here. Make filter like filter 22, but instead of RGBA subpixels, we use CMYK subpixels. Okay, so then what I'm gonna do right here is I'm gonna go copy this message here really quick, and I'm gonna paste that here, and that's not really what I want. I want the, yeah, there we go, boom, 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 boom. Okay, and then maybe I'll go, you know, forward this really quick to the main chat, right? Okay, and then now that we have that, it's just good to make note of that, because if I don't make note of it, I'm gonna forget about it. Okay, so now, I know like this video is like, oh, I'm explaining the filters, but the thing is that I don't really have confidence that many people are gonna watch this, and so I want to make sure I get some work done while I'm explaining this shit, right? Okay, so 21 we explained, 22 we've been explaining way too much, right? 22, the 22 being the subpixel filter. Okay, let's go on to 23. Okay, so 23, Newton's four-way gas pipe. Okay, so so 23 is a filter that treats every single color channel as basically gas, and that letting that gas diffuse over time, right? So it doesn't look like it's doing anything, but if we keep on using it enough times, I really gotta spam this, but you see that if we use it enough times, it is doing something, right? It is diffusing the red, green, blue, and alpha, and I do not believe that it that the different color channels here are interacting with each other. And you see that there's a number 1. So I believe that the number 1 and the number 2, number 3, 4, all of these are just different intensities. So 26 is probably like, if we hit enter, we're actually going to see something. Yeah, 26 is pretty intense. And then 3 is probably somewhere in the middle. And then 2 is in the middle but lower, right? And that checks out, right? Because we see 1 barely does anything. 2, you can see something, right? 3, you see a little bit more. And 4, you see a heck of a lot, right? So Newton's four-way gas pipe, right, which there's a few variations that are distinct, right? So when we make variations of a filter in PHOSIMP, we want the variations to be distinct. Not just different, distinct. So at a glance, you don't have to do a side-by-side comparison. You can obviously see that they were different, right? So 23, and then 24, right? And then 25, and then 26. Okay, so they're all different. So I think that the gas pipes, they make sense. So the gas pipes are 23, 24, 25, and 26. Okay, so we also have this 27, 28, 29, and 30, and these are also called Newton. They're also named Newtons, but not, they're called collective gas, right? So I know that these are also based on the same principle of diffusion, right? Like treating the pixels as gas, but the algorithm has changed, right? I know that one of these has the whole like conservation of mass or the conservation of matter, right? So like matter can not be created or destroyed, right? So if one pixel is losing red, the other pixel is gaining the same amount of red because the intensity is flowing through the image. Now, I don't know if, I can't remember the difference between Newton's collective gas and Newton's four-way gas pipes. So we'll have to look at the actual source code to see the difference. I'm sure that visually we're going to see a difference, but I don't remember exactly how the algorithm works. So let's use 27 here and just see what that looks like. Okay, so once again, 27 is very subtle. I have to keep on spamming the keyboard with 27 to actually kind of see something happen here. But something is definitely happening here. I'm noticing that we're starting to get transparency in the image because I'm seeing stuff glow. So that means that there's probably some cross-channel access going. So the Newton's collective gas for this is probably working off of luminosity somehow, or the flow, the intensity of the flow is based on taking the red, green, blue, and alpha and turning that into a single number, and then somehow moving things around based on that single number. That is, I could be full of shit because it's been a long time since I wrote this, right? But that's number one. 27 is the number one version. So 28, I assume is going to be a bit stronger, right? So 28, a bit stronger for sure. Okay, reset that. Okay, let's use 29. Okay, yep, a bit stronger. And then 30 is going to be the strongest effect, right? Yep, 30 is the strongest effect. And if we keep on using that, it just completely degrades into complete shit, right? And I would assume that 27 will also degrade into complete shit, but it'll take like a really long time, right? So we're just going to spam 27 for a second and see if it kind of degrades. And it might not degrade, even if it degrades into complete chaos, that chaos might not look the same as the stronger filter, right? Because it's very cellular automata. Okay, so now we basically made a fingerprint. Well, that's kind of interesting, right? Okay, so 28. Let's go spam 28 and just spam 28 until it degrades. Okay, and then 29, spam 29 till it degrades. Okay, and then 30, spam that till it degrades, and it only takes like twice. Twice it degrades. Okay, so I am curious about the difference between these. So let's go into source code and let's go figure out the difference between Newton's four-way gas pipe and Newton's four-way gas pipe and the Newton's. Oh my god, I'm a little bit drunk. And somebody's in chat. Hold on, let me put this over here. Oh no, it's just a bot. We gotta ban the bot. The bot is best promo. Blah 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 blah. Let's see. How do we do this? How do we ban this person? Ban. Okay. Anyways. Okay. So. Yeah. Yeah. You're gonna ban you, motherfucker. Okay. Anyways. So actually we have to make you a moderator because we make everyone a moderator who enters chat. Okay, so let's go look at filter 23. Yeah. So we're gonna go Control F and we're gonna go F PHOSIMP 023 and we're gonna find filter 23. And okay, so we see like we see some explanations here, right? The little four-way gas pipe and collective gas, right? And let's go grab onto this and go look at the code, right? So the code, we see that filters 23, 24, 25, and 26 share the same code, right? Because we have 4 variations with 4 different intensities, right? So inside of here, we see that it takes a gas diffusion coefficient, and for the different intensities, I guarantee the different intensities are larger or smaller gas diffusion coefficients, right? So if we grab onto this, right, and we see the call sites for PHOSIMP 23, 24, 25, and 26, we see the gas diffusion coefficient of 0.5, 10, 20, and 80. Okay, yep, that makes sense to me. Okay, so so we know we're basically treating the pixels as gas. Okay, now what about the other gas pipe filters, 27, 28, and 29 that come after that, right? We know it's still diffusing, but what is the difference here? And okay, so this right here, okay, so I see this is the shared function, and then if we scroll down at here, we're gonna see that, okay, so we see the same coefficients, right? 0.5, 10, 20, and 80. Okay, so both sets of 4 functions have a gas diffusion coefficient. So the question is, what is the difference with the variation, right? And yeah, gas diffusion coefficient, GDC right here. So looking at the code really quick, NGP all macro. I'm actually surprised how concise this function is. 4 gas planes, Newton's gas pipe. Okay, well, I guess what we can do is we just can look at the source code and kind of figure out the difference. Oh, is the first one with luminosity? Gas pixel cord. So the code is obviously different because we see it do different things. We got a little function here. Newton's gas pipe helper function is the other one using Newton's gas pipe helper function. It is, but we're only using it once here. Newton's gas pipe all. Oh, okay, I see. Divided by 4. Okay, so basically, I see what we're doing. Okay, so I don't know exactly what we're doing, but I know the basic idea, right? So, the first set of Newton's gas pipe functions, the diffusion, how strongly the diffusion happens is per color channel, right? And we diffuse the red, we diffuse the green, we diffuse the blue, we diffuse the alpha, right? And for our filters 23, 24, 25, and 26, those are all separate gas channels, right? So we have like a gas diffusion simulation that is happening on all 4 color channels separately, right? Now, when we go down to the next gas pipe algorithm that's used for filters 27, 28, 29, and 30, we still have 4 gases that are diffusing, but the diffusion rate for every single gas channel is based on the luminosity of the pixels, right? So even though we have 4 different gases that are flowing around on the 4 different color channels, red, green, blue, and alpha, even though we have those 4 different things, the diffusion itself is just based on the luminosity of the pixels. So now the reason for that is because sometimes things get more interesting when you tie the individual channels together in some way, right? Because if you make a really interesting filter, but you realize the filter does all the math with one color channel, does all the math with another color channel, and then another color channel, another color channel, it's like that feels kind of cheap, because then you realize that you didn't really make a filter that looks at the pixels. You just made a filter that looks at every color channel and runs that filter 4 times, once per color channel, right? And so sometimes you want to somehow get some type of aggregate number by combining the red, green, blue, and alpha of the pixels, so that whatever the behavior of the filter is, it's based on the gestalt of the pixel rather than an effect that is isolated to the red, green, blue, and alpha channels, and there's no interaction with the individual color channels, right? The color channels are just like in their own separate parallel dimensions, and you just happen to be doing a similar effect on each of them. I don't know if that makes any goddamn sense, but it makes sense to me, and I think I've done enough explanation. So basically, so filter 23, 24, 25, 26, we are diffusing the red, green, blue, and alpha channels as if they are gas, and the strength at which they diffuse is isolated to the values in each individual color channel, right? Then for filters 27, 28, and 29, and 30, we're still treating every single color channel as an individual plane of flowing gas that does not interact with the other flowing planes of gas, but the flow rate for every single channel of gas is tied to the luminosity of the pixel. So that basically creates an interaction between the 4 color channels, right? The 4 color channels in Newton's collective gas are interacting with each other. The 4 color channels of Newton's collective gas are interacting with each other, whereas the 4 color channels of Newton's 4-way gas pipe are not interacting with each other. I don't know if that makes any sense, but this is why it's like people want an explanation of what the filters do. It's like, you don't know. I've been doing this for like 20 years. I am so, what's the word? Far gone, right? Where like you've been doing it so long that you like have your own goddamn language for what you're doing, and it's like I can't really explain what I'm doing very well. It's like, just look at the cool pattern, okay? Just look at the cool pattern, bro, and just relax, right? Okay, so now that we've kind of explained what we're doing, let's make something cool, right? Let's make something cool with all the filters we explained so far, and try not to use any filters we haven't explained up to now, right? So, using filters 1 through 30, can we make something cool, right? And I think we can. So, first of all, sorry, we already went too high there. I'm a little bit drunk. Okay, so the collective gas filter, which is, what was it? It was 23 is the first collective gas filter. Now it doesn't appear to do much, right? But I know that if we like were to channel split a whole bunch of times, and then we were to use 23, and then we're to try to merge it back together, we might actually see something happen. I already kind of see something there, right? So what we're gonna do here is we're gonna reset the image, and we're gonna go open up this. Where's our fucking console? We have a console somewhere, and I'm gonna put this console over here on this side of the screen, and then I'm gonna hit R for reset, and R for reset is letting me down here, huh? What the hell happened to our log? Did our log just kind of poop out on us? Because I'm hitting R for reset and I don't see shit. Let's kind of do some blah 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 and hit enter. No? Okay, let's do 777. Okay, so I see 77 here, but there is no indicator of when I used reset. What the hell? Usually it will... My god. Okay, so, I guess we're just gonna have to... We're gonna have to fix this log to where when we hit reset, there is a message that tells us that we're resetting. Because I don't know what the fuck is going on. So you know what we could do? We could do 0 a whole bunch of times, right? And then we can see those zeros in the console. Okay, so what we're gonna do is we're gonna do 5, 5, 5, 5, and 5 until it just breaks apart, right? 5, 5, 5, and 5. So that was 4 times? Yeah? We can just look at the log. 1, 2, 3, 4, 5. We did 5 times. Okay, so now we're gonna do 23, which was like really subtle, right? And then we're gonna go 6, 6, 6, and 6 and put it back together. Have I lost count? I've lost count. So we see that there's a little bit of weird stuff going on with that, right? Let's do 5 and 5, and then let's do 23 and 23 and 23, and then let's do 6, 6, and oh my god, we went too far. Okay, so we have something kind of happened in there. Okay, so now let's use just a gradient ramp on that. Okay, and then let's do 11, and then let's use 5 again, and then let's use 24, which is stronger, and let's put it back together with 6. That was way too much. Okay, way too much, but oh well. Okay, so now we're gonna blur it like vertically, right? Okay, and then I really want to just only use the filters that we've covered so far. So let's use 16, and then let's use the halftone filter, which is I believe 22, right? And then let's use 11 to kind of merge things together. Well, now we just got red, which is like, maybe I regret that. Maybe I regret that, you know. Let's blur that horizontally. Let's put a gradient ramp on it. Let's blur that vertically. I don't know if I can make something without leaning on some other filters, so I'm going to use 137. I know that I said I was going to try to like not use any other filters, but I think we've reached some hard times here. 190 I think should add some color. 333. Let's use 333 until we get some just random color to pop up. Let's not do that. Let's do Okay. And then, let's use a random auto-tiling filter and another random auto-tiling filter. And then let's interlace those pixels. And then let's use another random blur filter and another random blur filter. And then a gradient ramp on top of that. Interlace those pixels. Okay, that's looking interesting. 2, 3, 4 to lighten that up and see if anything's hiding in the dark. Nothing really is. 240 to make it dark and scary. We can do 1111 to mirror that around. We can blur that a little bit. Okay, you know what? Even if we make something by now, it's gonna be too long. It's gonna be like too long of a recipe, and if it's too long, we can't put it into the source code for PHOSIMP, right? You know, like I like this. I think we made something kind of cool, but it may be more than this may be more than a. So we gotta look for our zeros, right? These are all of our zeros. This may be more than 64 steps, right? So we're gonna go over here to our text editor. We're gonna go File, New, and we're just gonna go paste that in there. Okay, 60 steps. 60 steps. Yeah, we can do that, right? You can even add. We can add 4 more steps if we really want to, right? I don't know if we should, but we could. We could do like 555. And then we could blur it vertically. And then we could use 556 and put a gradient ramp on it, right? Nah, let's not do that. You know, let's not do that, okay? I think that we have something kind of crazy here, and maybe we should just try it out, right? Okay, so what we're gonna do here is we're gonna take these steps here, these 60 steps, and we are going to go desktop, delete me. We're gonna find that bug folder. My folders are like, there it is. Okay, so we're gonna save this as recipe.txt here. I do want to replace it, and then what we're gonna do is we're gonna go into here, right, and we're gonna make a customization. We're just gonna. Oh my god, I didn't mean to press that button. I really need a cancel button, because like sometimes it's like, oh great, now I'm sitting here waiting for this to stop, cause I don't want to be here right now. I just accidentally clicked that thing. If it's annoying the hell out of me and I made the software, then imagine how much it's gonna like annoy people using it, right? Okay, so we're gonna go import the file that we just made, right? And then we're gonna run it, right? And the reason we're doing this is we're just making sure that we're not crazy and that these are indeed like all the steps we had, right? That, you know? Okay? So if we get the same thing that we made that has that cool, like, interesting pattern, right? Then we can say, oh, all right, then it's the thing, right? It's the thing we made. Yay, okay? Okay, so that's the thing, right? Okay, so what we're going to do now is sometimes, because this is a very chaotic system, if we use a different image, we could end up with like complete trash. So we really do want to test out our customization a few times with some different images and just make sure that, yes, this can be chaotic to where you'll get something totally different, but we just want to make sure that with whatever chaotic thing happens, that it just looks cool, right? If we get like a complete black screen or a complete white screen or just something that looks horrible, then we have to rethink the recipe, right? Because this, right now, I'm not quite impressed, am I, right? That's not quite as interesting as you would think. You know what, though? That might be a case for, we have these extra slots. That looks like a case for why we might want to do a filter 240, because there might be something hiding in the dark. So like if we put a filter 240 on it, and then we could do two 240s, right? Let's run that again. Let's run that again and see if that brings out any more detail or if it just makes it dark and horrible. And then we'd have to check and see what happens to the original image we were using, because that could make things just look... We'll just find out. We'll see what happens. Also, we have a normalization function, so we should probably try that out as well. Okay, so we haven't done the 240 yet down here, but let's see what happens. Bam, bam. Okay, so I would say, nope, that 240, bad idea. We need to make a button that just zeroes these out so I don't have to like twiddle them like this because this is some bullshit. Okay. So, let's go run this, and then while we're running that, I want to go look at my source code because I was designing filters for color correction for like if there is kind of like out of bounds colors, like scanning the entire image and normalizing things, like normalizing the dynamic range of the entire image so that things just show up. So 1290, 1281 is probably the filter I've made. PHOSIMP 1281. Let's go look at 1281 here. Well, actually, we have some documentation. We started to write documentation. So, 1281. I don't think I actually made these other filters yet. The first visible spectrum pole of 10. This is the simplest method I could think of to scan the image without out of bounds. Okay, yeah, 1281. We're going to try 1281. And we're going to see if it brings anything out. So we're going to go here, and the very last step will go 1281. Okay, we're going to run that again, and we're going to see if that magically color corrects things and brings out a lot more detail, because I think that it could. It could. It's not guaranteed, but we should see. We should see. Okay, so so we know that with this image, we're not getting as much intricate detail, right? We're getting these little specks. And that maybe that 1281 right down there might bring something out. We're about to see, okay? And I would say, nah, not really, right? I'd say that 1281 is kind of meh. Okay, so what we're going to do is we're going to go back to the main menu. And actually, you know what? No, we're going to go back to customize. And we would really have to shift things around. Okay, we're going to go into the recipe here because editing in the actual editor is not quite good. If we were to 1281, if we were to normalize the image at the beginning of the process, we might get less chaotic outputs. So this could make things consistently shitty or consistently more interesting. So we're gonna go back in here. We'll zero this out and we'll go import recipe.txt again, right? Because we put that 1281 at the beginning, right? So now we're going to run this, and we're just going to see if that color correction step at the very beginning drastically changes the output. And it's not looking like it. It's not looking like it at all. So we could try some other things to, oh, that looks a little, no? That does actually look a little bit different, doesn't it? Like, these little blobs are much bigger, aren't they? Okay, so let's go back to the main menu. Let's go load the other image, right? This image here. And let's just make sure that, remember how I said that things could end up consistently shitty, right? So let's make sure that that color correction didn't lead to things being consistently shitty where we don't have any big shapes anymore with any image. It's just all little dots now. I think I'm going to allow this, right? Like if this has the big intricate shapes, I'm just going to allow it, right? Because that means that if we morphed one face into another face in an animation, and then we put these recipes on every single frame of the animation, we would get these little blobs that turn into this chaotic big pattern. And I think that would be really cool to test out in some stuff. So I'm going to say that this pattern here, we're going to ship it. We're going to say, you know what, this pattern is chaotic. It does different things with different inputs. It does, right? So we might want to try one more image, right? We might want to try this doggy. And we'll go run that customization filter again. And we'll just see what we get this time, right? Do we get something that's complete shit? Do we get something that's kind of like in the middle of the last two? What do we get, right? So it's fun to have this element of chaos where like sometimes you get something really cool and sometimes you get something shitty depending on like what you put in. Okay, so we got something that's more blobby than the other thing. It's less stringy. Okay. Let's go use one more thing. We're going to go load. And we got this little dragon thingy. I don't know what the hell this is. Customize, go here. Okay, so we're gonna run this one more time. And depending on what we see, we will say that it's good or it's bad or whatever, you know? So the cool thing with this is if you ever see this pattern loading and you're like, oh my god, it was so cool up to here, and then you wrecked it, you can go into the editor and you can fix that, right? Okay. All right. So that's cool. That's cool. Okay, so I'm going to say that this is acceptable. And we're going to take this and we're going to re-export it. We're going to re-export over the recipe.txt, and we need to change this thing that says PNG files because this is a text file, but one step at a time. Okay, so now if we reload this, right, we have these nice numbers here, and we're gonna overwrite the source code for slot 274. So we're gonna go here and we're gonna, first of all, before we overwrite slot 274 here, 274 I know has random numbers in it, but let's just make sure that those random numbers don't actually do something cool, right? So if the random numbers actually make something that I really like, then we'll save it, right? This, no, I don't like it. I don't think it's interesting. Maybe you do, too bad, right? Okay, so 274 is where the next piece of code is gonna go. Let's go put this over here on one side of the screen, okay? So what I'm gonna do here is I'm gonna say 274, and we'll call it chaotic stringy blob brain, right? Okay, I'm not gonna try too hard for the names, right? Because it's like, how do you describe the weird things you're doing, right? I don't know. Okay, so 274. And then we're going to grab onto 275 to get to kind of around where these recipes are. And so 274 here just has random numbers, right? So we're going to take this little piece of commented out code and we're going to put it up here to have our visual marker of kind of where we left off working. We know that this right here is bullshit, so we're going to just delete that bullshit right there. And then we're going to go into our recipe.txt that we made. And all these numbers right here, we're going to kind of consolidate them so that we can kind of inject them into the source code, right? So here they are. Grab them, go into PHOSIMP.c11. We're going to paste that right there. And this won't actually work, right? Because the zeros in front of things make them octal numbers, and we don't have octal numbers. We have decimal numbers. And so I have a hackish solution where I made macros for every single filter number so that we can still display them with the padding that we desire, but have them interpreted correctly. So we're going to kind of cosmetically fix our numbers as well as add the necessary commas between them. And there we go. We got a recipe that we've handmade. And then we're going to make a commentary for this that'll bring us back up to the top of the file. So this is filter 274, and it's like chaotic blob brain or something. Chaotic blob brain. I don't really care. I'm just gonna write something. The thing I really care about is this token that has the $signs around it, because that's like our poor man's hyperlink that brings us from the actual recipe source code to this kind of little summary here. That's what I really care about. Okay, so now, if we are to close the code, right, close the program, and we recompile this, what we're gonna hopefully see is that when we go to recipe 274, we're gonna see that thing that we worked on, right? And then after this, we will end the video. We'll actually make one more pattern. We'll summarize all of the filters once more, and then we'll make one more cool pattern, and we'll end the video on a cool pattern, because I know that if people are watching this, they're not gonna watch the whole thing. No one's gonna watch the whole thing. They're just gonna seek through the video. This is the wrong piece of software. What the hell did I do? Close that. Oh, this is not even open yet. This didn't even compile yet. Oh, we got a chat. Oh, hey, there we go. Vivi D. Oh, how's it going, Vivian? and I'm working on a new program. Have you seen the have you seen this program that I'm making that makes like psychedelic art? I can give you a quick demo. Okay, so hold on for a second here. This is oh, I have the wrong build script, but I can show you this right now. Okay, I'm gonna run this build script for one piece of software. I'm gonna put that on another monitor, and I'm gonna run my other build script for another piece of software. We're gonna compile two pieces of software right now, right here for you. I'm slightly intoxicated. Okay, so last month I made $900, which doesn't make me rich, but next month I'm probably only gonna make like 100 to 300. So I'm like, I'm not too excited about that, because rent is 500. But hey, you gotta start somewhere, right? Okay, so I don't know where's my other build script. What the hell is going on with my other build script? PHOSIMP, the faux face build script is still running. Okay, so let's okay, there we go. There we go. There's another piece of software. Okay, let's put this on the other side. Okay. So, where are you in chat? We'll give you a demo of one thing and then the other thing. No, not yet. Okay. So, this is called PHOSIMP. And the way it works is that every different number that I'm pressing is like a different Photoshop filter, basically, right? It's like Photoshop on steroids. It's like Photoshop hotkeys, right? So like I'm just using the different filters in order right now, right? So 14, hit enter, 15, right? 16, 17, right? So 17 is like really expensive because it's like a very big blur that kind of like freezes the program, and like I really need to like work on the UI to like make people know that it's still like working on stuff, right? Okay, so we made this cool thing, right? Okay, cool. We made a cool thing. Does it perfectly tile? Let's make sure it perfectly tiles. Let's go 330. Let's go 33 for a second, and move it around, and 32, and move it around. I'd say that tiles well enough. You want to use 900? We actually do have a filter 900. Before we do that, though, we made something that's pretty cool. I would like to put this into the recipes for the new product that I'm working on. So first of all, what I'm going to do is I'm going to take the console for this software. I'm going to put it over here really quick, and I can see all the numbers that I press. So I'm going to grab those numbers, and I'm going to copy them, and I'm going to put them in this thing called recipe.txt, and I'm going to clean it up a bit. I'm going to get, first of all, this is not a number. And, okay, so here's the numbers I pressed, right? Okay, they're in a file called recipe.txt. Why is that important? Because now over here, I can go to the customization menu, and every single preset that is in here can be overwritten. I'm going to select this empty slot in the bottom, and then I'm going to go import the file that's to the right, right? So I'm going to go import this, and then I'm going to run it. Now, this time I'm running all the steps, but on a different image. So we will probably see we're going to see something similar but different, right? So okay, do we like that? It's definitely different, right? This is definitely different, but it still looks cool, right? As long as it still looks cool, we're good, right? So for example, if we go back here and we go load the original image we used, let's make sure that when we load the original image that we used, that it actually looks like what we think it's going to look like, right? Because we have this still open. This is still open, right? So if we did this correctly, whatever happens over here on the right should look exactly like this, right? And if it doesn't, then I don't know. We have to give back our coder license. Okay, there we go. It looks exactly the same, right? So this is a pretty cool recipe, right? Okay, so what we're going to do now is this is kind of a bad formatting, right? So what we can do now is, now that this recipe here has been loaded into the editor, we can just re-export it. So we're going to export it, and we're going to overwrite the recipe.txt file, and then we're going to save it, and we're going to replace it, and then we're going to reload this, and now we got some beautiful formatting, right? Look at that beautiful formatting, right? Okay, let me go open up chat over here. Oh, 900, you meant, oh, I have 1,1281, I think. I think that's where I am. I can actually look at the source code right now. I can tell you exactly what we're at. So once I get some loose ends tied up, we're going to have 1,1290. But really, we only have 1,1281 in the source code right now. but this new update hasn't been pushed yet, so I'm still working on 1282 to 1290, which are some like they're like some high dynamic range correction filters, because the reason that we can make these psychedelic graphics in our program is because the color range is like 64 bits per pixel, so you can stack transformations without losing information. I could actually show you that really quick. Hold on. Before we show you that though, let's get this new recipe into the source code, right? So the next slot that's available is going to be 1273. So we're going to go back here, and we're going to hit 1273. This is 1273. 1273 has random numbers put into it, but those random numbers might actually make something cool. They usually don't, though, right? So a lot of people are watching my Instagram videos and being like, bro is just randomly pressing buttons. Yeah, no, I'm not. No, I'm not. There's a little bit of randomness, but there's actually like a little bit of a strategy of like, when you see something get too noisy, you put a blur on it, right? When something is getting too flat, you put a gradient ramp on it, right? There's actually a feedback cycle that goes into me making these patterns, which is very obvious when you just randomly spam stuff, right? Like, we can go into customize here. We can go into customize, and let's make a new slot like over here, okay? So we can actually zero all these out, and we can just do random. We have a randomize button. We can just do random. Here's some random numbers. You want some random numbers? Okay, random numbers. There, we got some random numbers, right? And random number, this many random numbers very rarely will make anything cool. It'll usually just devolve into noise or like a flat color, right? That's usually what you're going to end up with, right? And so because of this, I realized that I make the software look a lot easier to use than it is, right? So people will buy this program to the left because they see how easily I made something really cool, and then they try to use it and they can't make anything cool, and they feel like kind of like they're cheated, right? So the program to the right is basically like a recipe book, right? Where it's like, I'm going to make a whole bunch of preset recordings where I actually make something cool, and then if you want to edit those yourself to have some authorship over it, you can, right? That's kind of what that is going on here. Okay, so we're looking at the source code, and we said 273 was the next available slot, and we tested 273, and 273 looks like shit. And that's good, because that means that we can go find slot 273 in the source code, and we can overwrite it. So here's slot 273. We are going to just nuke these numbers because they look horrible, right? And I have this little template here in my source code. I'm going to move that template up past where we're working. And then we're going to inject the new recipe into here, right? So here's our recipe.txt. First of all, we don't need these zeros. These are all zeros. We don't need to specify the zeros. And this is our recipe. We're going to go into kanji coder. We're going to go here. Okay, so we're going to paste this here. Now, if you're familiar with octal numbers, you'll realize that this is not actually 13. I don't know what it is, but it's not 13 because octal numbers start with 0. That's okay because we made some macros to fix this really quick. So I made these identifiers with double underscores. So we got to clean some stuff up, right? We have to do a little bit of cleanup, but the cleanup isn't too hard, right? The cleanup does not take too long. All right, there we go. So now what we can do is we can close this and we can rebuild it, right? So I have the faux face build script over here, right? Oh, no, that's PHOSIMP. Where is, let's, oh, no, it says I know, okay. Anyways, we're gonna go run the build script. Let's go put it back over here. And then we're gonna try out filter 273 and just make sure that filter 273 makes this now, right? Filter 273 should make this. And if it doesn't, then we done something wrong, right? So where is Chatty over here? Wow, that's awesome, thank you. Yeah, it's like, I'm not rich, right? I'm not rich yet. I say yet, I mean, being positive here. So I'm hoping that, like, here's the plan, right? I made, like, for my second product, it looks very similar to the first, right? Like, the UI looks very similar. but it's actually a reusable user interface library, right? This user interface was like hacked together, and I made it a very minimalistic user interface so that I could actually finish what I work on for once, right? Because you know how I make these ambitious projects and work on it for like 5 years and then it ends up getting trashed, right? I don't want to do that anymore because I actually want to make money, right? So this user interface here kind of looks exactly the same, but it's a reusable interface library. So that means once I make my third game, right? So my first game is over to the left. My second game is over to the right. Once I make my third game should be a lot faster to publish because the whole user interface library framework that I used for this game to the right can be reused for the third game. Does that mean that all of my games are going to have this really tiny square interface? Yes. Does that make for good branding? It sure does, but that's just a coincidence, right? It's a coincidence that all my games are these little squares, right? I do think it'll be good for branding, but the point is just to keep the scope very small, keep these very small, simplistic UIs. Once I get up to 10 games, then I will rethink about like making a more sophisticated UI. But for now, we want to think about like we are like digital gumball machine vendors, right? We're selling little tiny games for 99 cents that deliver more value than what you expect for 99 cents, right? That's what we're going for, okay? Okay, so according to our source code, 273, right? So 273 is this number right here. Let's go click that. Now, it's not going to match exactly because this was a different photo, right? But we've ran this a few times already, so we already kind of remember that, yeah, that's what I saw with this photo earlier today, right? So what we're going to do now is we're going to go back to main, and we're going to go load a different image. And we're going to load this one, because this is the default photo in PHOSIMP. And then we're going to run it was 273, right? According to our source code, 273. Oh, somebody chatted us. Let's go check chat. Okay, so while that's running, let's go check chat, which is, where's chat? Chat is right here. Nod, got it. Okay, so, okay, there we go. Yep, there we go. Perfect match. Okay, so now what we want to do is we want to just use one more photo. We just want to use one more photo to make sure that you can see how there's this chaotic output, right? There's this chaotic output, and it's fun to have that chaos where you get something different depending on putting a different image in, because if you don't get something different when you put a different image in, what fun is that? But we want to make sure that even though it's chaotic, that it's consistently interesting, right? So that is quite different. This is quite different than the other two, right? But we have something interesting, right? Oh shit, hold on, let me read that. I'm slightly intoxicated. Let me read this though. Plane is taking off. I might be home for a hot minute. Oh, you might home gone. Yeah, okay, I got you. Cause the plane and access to the internet through the phone might not work on the plane. I got you. Okay. So now imagine this, because I know you can imagine this. Okay. So imagine that we eventually want to make psychedelic animations, right? Not with this program, but eventually that's where we want to go with this. Because you see that when we put this dog in, we get a totally different output than when we put in this girl, right? So you know how like we have like Animorphs? You know the Animorph book covers where they like morph like a person into like, I don't know, a fucking squirrel or some shit? So imagine we make an animation, a morph target animation, where we change this girl into the dog, right? And then after we make that morph target animation, we do all of these steps on top of every single frame of that morph target animation. What is that going to look like? I have no clue what that's going to look like, but I guarantee whatever it looks like is going to be something people have never seen before, right? It's going to be what I would call, what I want to create is what I'm going to call a non-naive kaleidoscope, right? I want to create some psychedelic, trippy animations that are non-naive. So when you look at it, you're not like, oh, that's just a stupid kaleidoscope. I don't want people to say that. You know what else I don't want them to say? I don't want them to say, oh, that's just a Mandelbrot, right? So all the trippy graphics that we have so far are basically either a Mandelbrot or some stupid ass kaleidoscope, right? I want to do something that's different. Now, will most people appreciate that I'm actually doing something different? Probably not, right? But some people out there will, right? Okay, so we did something 273. We do want to end the video creating something interesting on the fly, and we went through kind of a whole workflow of like embedding this graphic into the source code. So the last thing I want to do is make one more cool thing, but I'm not going to do the whole embedding step on the recording, so that we can kind of end the video on a higher point than we would if we ended the video now, right? So what we're going to do here is we got that recipe in the source code. Though we forgot one little busy work step. We still have to add a tag, right? So this is a recipe. This is recipe 273, and we have to have the R in front of that. And first few filters in order, right? That's basically what we did. We basically did the first few filters in order, right? And that's how this effect was made. So I guess that's what we'll call it, right? So then we'll go up into the documentation for these little display names. And I know it's not a very creative filter name. 273 is first few filters in order, right? And we did other stuff, right? But we started out by doing the first few filters in order, right? So there we go, 273 right there. So now if we grab onto 273, I got this kind of poor man's hyperlink where you control F between the display names of the recipes and the actual recipe, right? Okay, so now we're gonna do is we're gonna go back to here and we're gonna reset this and we're gonna go open up the logs. Okay, so this is, that's why, okay. So this is PHOSIMP here. We see this little can't compare like that in C. That's gonna be our, we really need a reset message, but this is when we reset. When we reset, we see this message. We need to work on that a bit. Okay, so we know that 23 was like the Newton's gas pipes, and we really want to mess around with those a little bit, right? So I don't know, we could do like 4 and then 24, and then we could do 4 again, and then 22, and then 24, and then 1111, and then maybe we do 24 again, and then we do 137, we interlace that, and now I'm thinking that's a little bit garbage, and then we could do 24 again, and then we could do 22, and then we do 1111 to split it apart into quadrants, and then 377, and then what was it? Let's do filter 29. 29 is a little bit too strong. Well, let's just do it anyways. Okay, let's interlace this. So now what I'm seeing here is trash, right? Like, I don't know if we can recover this. But it'd be interesting to see if we can recover this into anything. So we'll mess around with it, and we'll just see if we can make something happen, right? 5 and, oh, that's kind of interesting. 5 and 5, 4, 4, 4, 555, 6 and 6, and then 137, and then 377, and 137, and 377, and 137, and then 377, put a gradient ramp on top of that, a 4, okay. 137, splice that together one more time. Let's do 1111 to make it symmetrical. Let's blur that vertically. Let's put a gradient ramp on that. And then let's interlace that one more time. 377, 137. Let's do horizontal blur. And let's do a 25. Let's do a gradient ramp. Let's interlace it. 377 to soften it up. Gradient ramp. 137. Okay, soften it up. Okay, and then gradient ramp. Okay, I kind of like that. That's interesting to me. Now, if we move it around, okay, we do have a little bit of a seam there. But we don't really have one here. And then let's move this downward. Bottomward? Let's put this back here, right? Okay. I like this. I think this is interesting. Now, the question is this too many steps? I don't think it's too many steps, but I'm not sure. We did a lot of stuff, right? So we're going to go into recipe.txt, and we're just going to paste this. Ooh, well, this is where we're moving it around. Here's where we're kind of moving it around. So without moving it around, we're actually at 60 steps. So this works as a recipe for PHOSIMP. So we're going to end it here because we made something cool off camera. I'm going to put it into here. I've explained all the recipes somewhere in this video for filters. Sorry, not the recipes. I've explained filters 21 to 30 in this video. So go buy PHOSIMP on Steam. PHOSIMP is only 99 cents. PHOSIMP, PHOSIMP. Go buy it on Steam. Make psychedelic graphics.